Okay, your note should say 3-10. That means it's chapter 3, section 10. Systems of quadratic, and it's also and linear equations. I just forgot to type linear. Okay, the essential question is, when you solve a system of quadratic and linear equations, what does your answer mean? Or what does your answer represent? Okay? The first type of problem we're going to do is solving by graphing. There's multiple ways you can solve these. And I'm going to show you all of them, and if the directions say solve this way, you need to solve it by that way. If it doesn't tell you which way to solve it by, you can you can pick your favorite. Yeah?
We already did this.
I don't think we did.
Yeah, I remember everything.
Cool. I'm glad. Maybe you already watched the video or something, or you dream about math. Okay. So, solve by graphing. We have two functions, y equals 2x squared plus 1. We're looking today at quadratic functions and linear functions. Stetson, this first one, 2x squared plus 1, do you think that's a quadratic or a linear?
Quadratic.
Okay, that's correct. Can you tell me why it's a quadratic?
Because of x squared.
Exactly. X squared is the highest power. Good. Okay, versus this one, Arya, what's the bottom function? Quadratic or linear? Linear, because it's not squared. It's x to the first power. Quadratic will be that u parabola. Linear is a straight line. Okay? So, solving by graphing, we're going to put them in our calculators. Grab your calculators. How do we graph on the calculator? Yeah, y equals. All right, I need to get my stickies because I can't see both screens at the same time. Go to y equals. Clear out anything that's in there. Now at the top, make sure none of your plots are highlighted. If your plots are highlighted, your calculator is not going to want to graph. So type in 2. Where's the X button? Yeah, that O is actually, it's a O with a line. It's a Greek symbol called theta, which we'll talk about at the end of the year. But yeah, it's right next to the green button. X, where's the squared button? Diagonally up from the 7, right here. Okay, so 2x squared plus 1, arrow down, and write negative 2x plus 5. To make sure everyone's graphing on the same window, we're going to come up here to zoom. I want to make sure everyone's calculators are doing the same thing. Hit zoom, and I want to go to our regular window, which is negative 10 to positive 10. Which selection do you think that is? Standard. Z standard, number 6. So you can just type number 6. And we'll graph. Here comes the quadratic. Here comes the linear. When I ask you what are the solutions, by raise of hand, what do you think that means if I ask you what are the solutions?
What are the points?
Christian? So this right here. Okay, that's not a solution when we have 2. It's a solution if we have 1 graph, but not when we have 2. AJ? Where the 2 intersect. Okay, they intersect twice. So I'm going to teach you on your calculator how you can solve that. So I hope everyone's following along. Yes? Don't bring it up here, please. All right, look along the top line and see if you can find a calculate feature.
Oh, right there. Trace.
What's it right above? Okay, you'll have to retype them in, but it should be good now. It's right above the trace, and it's in blue. So you should go second, trace. Now, which one allows us to find the intersection? 5, intersect. How nice is that? 5. And see how we have this little blinking bug?
0 to 1.
You're going to, it's not 0, 1. You're going to arrow over. I'm going to start with the left intersection. There's 2 of them. I'm going to do the one on the left, the higher one. I'm going to arrow over until, see at the bottom of your screen it says first curve? I'm on the first curve, and I want to arrow over until I'm as close as possible to that intersection. Once I'm as close as possible, I hit enter. And it changes to second curve. Now, second curve means my little bug is now on the linear line. So I want to move left and right until I'm on the intersection as close as possible. I hit enter again, and now it says guess. I hit enter for a 3rd time. So essentially you hit enter 3 times. Okay, and what is the intersection? Good. Okay, what about the rest of you? What is the intersection? Okay, these two in the front, I hear Noah. I don't hear it from anyone else. What is the intersection? -2, comma, 9. Okay. Skylar, what was the intersection? Comma 9. Yep, so write that on your paper. I'll write mine in a minute. We have one more to do. There are 2 answers. Why are there 2 answers? Why are there 2 answers? Jeff? Because they cross twice. There's 2 intersections. So we need to go do this bottom intersection on the right-hand side now. What buttons do I push in order to get to that program? Count, but you have to go second trace. Okay, Noah, now what button do I push? Yeah, number 5. Now you move your arrow down to the right. It says first curve. Okay, down to the right until your bug is as close as possible to that intersection. Turn around, please. Turn around, please. You hit enter, and then you're on the linear line. As long as it's on the intersection, hit enter again, and enter for a 3rd time. Are you pushing enter? Okay, so what is our second intersection? Okay, write that down on your paper. I don't know what you're doing, but it's fine now. I just went back into the second trace and redid the program, and then it worked. Okay, so 1, comma 3. On your notes, make sure you write these as ordered pairs. Mikla, what was the first ordered pair? That was a solution.
1 and 2.
Did you get the last one? What was the ordered pair we just found?
2, 1.
Okay. I think we'll pick on Kevin to tell us both of them. And the second one? Yeah. All right, Kevin, be nice to your neighbor. Don't give him false answers. Oh, that was Stetson? Stetson would be nice to your neighbors. Don't give him false answers. Okay, we're going to do this again. Write down example 2. It's this green one. The first one, Stetson, is that quadratic or linear?
That's quadratic.
Quadratic. And the second one, Isaiah Cooper, is that quadratic or linear? What? I can't hear you. Linear. Good, because it's next to the first. All right, we're going to write both those down. Then you're going to grab your calculator and find their solutions. This is by graphing. On your homework, when it asks for graphing, you need to make sure you actually graph it on paper.
This one doesn't.
Interesting. So go back to y equals for the intersection. Okay, then go back to y equals and type both of them in, and I will go to my calculator when I see people are done. Okay. Stetson, have you typed them in? Everyone grab your calculators, type in your x squared plus x plus 3 and negative x. Okay? Yeah, when we ask for a solution, what are we looking for, Miriam? Where they what? Where they intersect. Okay, Miriam, where do these intersect? They don't. So, what would our answer be for the solutions?
No solution.
Ah, it's no solutions. Okay, on your paper, right? No solutions.
So if that has to have a homework, if you just type it.
Yeah. No solutions. Okay, on the right side, Miko, will you choose a seat, please? We're going to write down the steps of what we did with our calculator. First, we went to y equals, right? And we graphed them with the calculator. Write down your steps. We're going to do a third problem with the calculator, and then we'll do a different method that's not graphing. Step 1, go to y equals and graph both on the calculator. What did we do after we went to y equals? What? Brianna? To zoom, we wanted to make sure we had a normal window in case our window was messed up. Zoom standard. Then what did we do? Alexis? Second calc or second trace, got to the calc feature. We selected number 5, which was the intersect, and then we selected the intersection by hitting enter 3 times once we got the bug on it, right? Second trace, 5 is the intersection, and then we move our bug until we're on the intersection, and essentially we hit enter 3 times. I think that's the last one. Okay, so we're going to try one more. You have all the steps. Example 3, y equals 3x plus 4, and y equals negative x squared plus 4. Okay, Alex, the first equation on top, is that quadratic or linear? X to the first power, is that quadratic or linear? Because it's 3x to the first power. What's the other one? What's the other option? Linear. So x to the first powers are going to be a line, linear. Okay? So this one, x squared, Alex, would be a quadratic. That would be a parabola shape. All right, go to your calculators, please. Type them in. I hope you have them written down because I need to go to my camera screen. It was 3x plus 4. Oops. And negative, was it negative?
Yeah.
Negative x squared plus 4. Okay?
Negative.
X squared plus 4. All right, Justin, how do I go and calculate the intersection? Graph. Did these two actually intersect this time?
Yeah.
Yes. How many times? 2. Now there are some graphs that will only intersect once. It would be like when the line comes and just bounces off of the parabola. If it touches once, do you know what type of line that is? Starts with a T. We learned it last year. Tangent line. Does that sound familiar? If it touches once, it's a tangent line. Okay, Jeff, put your drink away, please. So this crosses twice, so we need to make sure we have 2 answers. So go through the process, please. Go into second trace. Number 5, put the bug on the intersection and hit enter 3 times to get our 2 intersection points. Yep, that's one of them. Okay. And you need to put parentheses around them. Then go do the second intersection. Well, you didn't square it. Those are both linear, so that tells me you didn't square it. So that bottom one, arrow down, put your arrow on the plus, and see this INS? That means insert. So go second, INS, and just insert the square. And now you can graph it. Okay, you need to go second, calc, number 5. The bug's almost on the intersection. Just hit enter 3 times since it's on the intersection. And that's one of the intersections. That's the point. As long as the bug is on the intersection, you hit enter pretty much 3 times. Sometimes the bug moves a little bit, so you just have to make sure it's on the intersection. You get both of them? Good. Good. Okay, you have about 20 more seconds. Let's see. I think you have an error on that one. Look at what you have on your calculator. Your calculator's right, but you didn't correctly write your point. Go back to second calc. Just redo the program. Oh, you're doing table. Second calc. Okay, number 5. Just hit number 5. Okay, just arrow till that bug is as close to the intersection as possible. Now hit enter, enter, enter. There you go. No. Alrighty. Let's see here. Isaiah Main. What's one of the solutions you got for number 3? Will you do it again, please? It doesn't take very long. Go through it again. Okay, you do the one on the left, Isaiah, and I'll get someone else to give me the one on the right. Nope. If you did a decimal, you probably weren't very close to the intersection when you pushed enter. Okay, Kaylee, what did you get for the point on the right? The more positive point. Uh-huh. The positive one. Well, it's on both. What was your solution that had the positive number in it? Yeah, 0, 4. Good. That's the one on the right, and the one on the left? Isaiah's going to get it for us. Do this one down here. That's the one we want. So go back into it. Second calc, number 5, and I want this one down here. So arrow down. Keep going just a little bit more. Now hit enter, enter, enter. Good. Okay, what does that say? Yeah, -3, -5. They're both negatives. Okay, that is solving by graphing. And on your homework, you're actually supposed to draw the graph on your homework. Okay, on your paper. So, I'm going to show you a shortcut to get some points. Because if you're drawing this, you need some points. Look what it says above graph in blue. Table. If you go second table, look at all these points. That Y1 is the first one you typed in, which I think was the linear. And the Y2 is the second one that you typed in, which was the quadratic. And they match with all of these X's on the left. So there's a shortcut to get some points. We're going to move on to example 4, which is solving by using elimination. You don't need to write this whole thing down. You just need to write the important information. Okay, raise your hand when you hear something important that we should write down. Solving using elimination.
Probably write that down.
Yes, you should probably write down solving using elimination down. And example 4. What? No, clear out your calculator, please. I shouldn't be doing it. Not right now. Since opening day, raise your hand when I say something important. Since opening day, attendance at pool A has increased steadily, while attendance at pool B rose and fell. Equations model the daily attendance Y. What should I underline? That's important. And not just Y. Daily attendance is representing Y. Pool A increased steadily, which means pool A was linear, which we see this down below anyway. Pool B rose and then fell. That's a quadratic. If you go up and then down, that's a quadratic. Okay, we need to know what Y is. Y is daily attendance, where X is what?
The number of days since the opening day.
The number of days since opening day. And then you should also write down the two questions. On what day or days was the attendance the same? Colby, you need to write these down. When is attendance the same? And what was the attendance on that day or days? You should also write down the equations. Okay. I'll give you just a second more. This time we're not going to be graphing them on the calculators. We're doing it by elimination. So, step 1 is to line them up. Okay, I'm going to write the longer one first because I want to line up the shorter one to it. Pool A, where should I put the Y? What's its like term? Oh, 39 is definitely not a like term. Y is a like term with Y, because they're both in the Y family. Okay, Chris. Do we have 2 Chris's in this one? No, 1 Chris, okay. Chris, where should I put the 28x if I'm lining up like families? 28x, which one should it line up with? Good. So we're going to leave a gap and put positive, and you can put a plus. I put a plus, I don't know why, but you can just write 28x. You really don't need that plus. And then the 4. Tyson, where should the 4 line up? With the x squared or the 64? The 64, because they're like terms. Now what we're looking for is for one of them to eliminate, yeah? You have a note? Give it to her. Okay, and put the phone in your bag, please. Okay, we want to eliminate down to one equation. So to do that, we're going to subtract like terms. If I subtract, that means everything's subtracting. It was a positive y. If I subtract it, it's now going to be a negative y. So the signs will all change. If I subtract a negative x squared, it becomes a positive x squared. If I subtract 39x, it becomes a negative 39x. If I subtract 64, it becomes negative. So we're going to go column by column. Okay? Dago, what is y minus y? Y minus y. 1 yo-yo minus a yo-yo. 0. Good. No yo-yos. 0. Nothing plus x squared. It's just x squared. Good. 28 x's minus 39 x's. Oh, you're really close. It's not negative 10. It's negative 11x. And it's not x squared, it's just x. And 4 minus 64, which is the same thing as negative 64 plus 4. Brianna? Negative 60. And we're trying to solve We're trying to find when does x equal 0. We learned this last week. Well, we've known how to do this for a while actually, but this in 2 steps what we learned was last week. So we solve by doing a math teacher's favorite F word, factor. Okay? Favorite F word, factor. We want 2 numbers that multiply. What goes on the top?
0, first times third.
First times third, so negative 60. We just had a test on this, and we add to negative 11. Please start thinking. What 2 numbers multiply to negative 60? Don't shout it out. Raise your hand when you think you know. What 2 numbers multiply to negative 60 and adds to negative 11? Real, make sure you're focusing. What multiplies to negative 60 and adds to negative 11? Okay, I have 2, 3 people, 4 people who think they know. If you don't know, then you start doing some division. You do a list. 60 divided by 1, 60 divided by negative 1, 60 divided by 2, 60 divided by negative 2, 60, you go in order until you find it. La-di-da-di-da. Okay, Omar, what do you have? 4 and negative 15. Does he have his signs on the right place in order to add to negative 11? Yeah. Negative 15 plus 4 would be negative 11. So it works. These are factors. We write factors in binomials. I'm going to give you a hint. You can go do the box now if you want, but here's a shortcut. When x squared is a 1x squared, this only works if it's 1x squared. Those 2 numbers you found are your factors, x minus 15 and x plus 4. You can do the box if you want, but you will get that. X minus 15 and x plus 4. The property we learned last week, does anyone remember how to solve from the factors? Yeah, exactly, the 0 property. Now I'm going to apply the 0 property to solve. Someone besides Christian Hansen, because he told us that answer. Who remembers what the 0 property is? To solve for x. Oh yeah, do you remember the 0 property? To solve for x when we have x's in the factors? And? Good, thank you. We take each individual factor and set it equal to 0. And then we just solve them. Justin, on the left, what would x equal? Good, because he just goes plus 15 on both sides, and that cancels out. On the right, Maria, what does x equal? 4. Yeah, it has to be negative 4, because we're going to subtract 4 on both sides to solve. And that would cancel out. Okay, now this is a story problem, so we need to make sure our answers are appropriate or make sense. How did I write this before? I don't remember. Use valid answers only. What was our story problem about? Swimming pools. What does X represent? Isaiah Cooper, look at the top. What does X represent? Number of days. Okay, Isaiah Cooper, is it possible to have 15 days? Is it possible to have 15 days? Is it possible to have negative 4 days that your swimming pool's been open? No. So we're going to cancel that one out. That one's not applicable to our problem because we don't have time machines. That answers the first question. The second question is, what is the attendance? So on day 15, both pools have the exact same attendance. That's why it's a solution, because the two graphs intersect. So on day 15 they have the same attendance, which is our x. How do we find how many people attended on that day? We know x. How do we find y? Y is the number of people who attended that day. We know x. How do we find y? Stetson? We know x. How do we find y?
You have to divide. I don't know.
Isaiah Cooper? Plug it in. To what, Isaiah? To what? Okay, Noah, do you know where we plug in? Which one? Does it matter? No, both of these equations you can plug into. Now one's easier, but no matter which equation you plugged into, you'd get the same because they were equal on that day. Which one's easier? The top one, y equals 28x plus 4. So now we're going to plug in x into y equals 28x plus 4 was the easier, less complicated one. You can use either. So we get y equals, type it in, raise your hand when you know the number, and you need to know what this number represents. Brielle, I need you to type that in, please. Pick up your calculator, please, and type that in. Gavin, have you typed it in? $28 times 15 plus 4. Isabella, what'd you get? 424, okay. Christian Hansen, you had your hand up. What does that number mean? Great. 424 people in attendance at both pools on day 15. Maria? Whoops. We got 15. Do you understand how we got the factors? So we took that factor and set it equal to 0 for the 0 property, and 15 minus 15 is the only way we can get 0. Okay, one more example. Now this one will turn into a problem very similar to the last problem we did. So last example, solving by substitution. Fix that. Solving by substitution. Write it down, please. Put your calculators down. You don't need them right now. Solving by substitution. Write both down. We have a quadratic, y equals x squared minus 6x plus 10, and a linear, y equals 4 minus x. Substitution means we're going to substitute one of them in. Like when I have a sub, because I'm sick or on a field trip or something, a substitute comes and replaces me, right? Does that mean substitute? It replaces? Yeah. So, we're going to, step 1, substitute one equation into the other equation. EQ is my abbreviation for equation, okay? Preferably the easier one. What does y equal on the bottom? 4 minus x. We're looking for where these two cross each other. So where they cross each other, right at that point, do those points have different y values, or is it the same y value? It's the same y value because it's the same point. So this y also equals 4 minus x. So I'm going to replace, I'm going to write this top equation, but instead of the y, I'm going to put 4 minus x equals the rest of the equation, x squared minus 6x plus 10. Or you can think of it as dropping the y's and taking the x equations and setting them equal to each other. Okay? You can do this as long as it's solved for y. Remember, our goal is to find the solution. So if there's only x's, we're trying to find the x coordinate. How do we find x? Yeah. So we're going to move everything so that we have 0 equals the rest of the stuff. So set it up. Combine like terms so that we have 0 equals something, 0 on one side and everything else on the other side. Skylar, what needs to move to the other side? We're up here. X squared is positive, so we want to get everything to the right side. What? Okay, how do you move the x? Okay, so I'm going to add x, and I'm going to choose to put it underneath its like term, negative 6x. Those are like terms, right? Okay, Maddie, what else needs to move besides the x? We want everything to the right. How do you move the 4? Subtract 4. Good. Now, which term should I put subtract 4 underneath? The x squared or the 10? The 10, because those are like terms. Is everyone okay that I did 2 steps on the same line? So on the left, everything cancels, so we have 0 equals. Tyson, can you help me write the right side, which means we're adding up the columns? How many x squares will there be? Good. And how many x's? Well, there's negative 6x plus an x is... No, negative 6 plus 1. Did you say negative 5? Okay, x. And then lastly, Tyson, 10 minus 4. Good. Plus 6. This should look like our last problem. How did we solve the last problem when it was set equal to 0? The math teacher's favorite F word. Factor. Factor. Starts following the exact same steps on the last problem. So we do a little x. Gavin, what do we look to multiply to? What goes on top? Okay, coefficients. First times third becomes what number? 1 times 6 is... Okay, and Gavin, what do we add to? Careful. Negative 5. Okay. Nico, what 2 numbers multiply to 6 and add to negative 5? Negative 2 times what? Is 6. Okay, that would make negative 6. How do I make it positive 6? And negative 2 and negative 3, does that add to negative 5? Yeah. Okay, so we can jump, as long as this is a 1x squared, we can jump straight to the binomials. AJ, what are the binomials? Okay, those aren't binomials, though. Jeff? Just minus 2, so not minus negative. There you go. Okay? Miriam, now what? Apply the 0 property. Apply the 0 property to solve for x. Okay, Stetson, what does that mean? Apply the 0 property. No.
Hit me.
No. Yes. So no on that one and no on this one.
Oh, wait.
What's the zero property? How do we do the zero property?
You like separate the two.
Mm-hmm.
And then equals 0.
So what equals 0? Good. And then x minus 3 equals 0. Take each individual factor, set it equal to 0. Okay, Alexis, what would this x value be? Good. So it's just the opposite sign, right? And this one, Alexis? Good. Okay, these are just x's. We want a solution, which is a point. If I know the x, Elizabeth, how do I find the y? What? Plug it in, plug it in. We plug in both of them separately. Plug in x to get y. Now, at the beginning, which equation looks a little more friendly to plug into? Yeah, that one, right? 4 minus x. Y equals 4 minus x. So we have to do both. 4 minus 2, which is what? 2. So that point is, who can tell me the ordered pair? X comma y. What are the numbers? Colby, what was the x that we plugged in? 2. And what was the y? What? We got it. Y equals 2. And on this one, we plug in 3. 4 minus 3, which equals what, Kevin? So, Kevin, what's the point? What? We plugged in what x value? 3, and we got 1. So it's 3 comma 1. Those are solutions. Any questions? Solutions, when you have two functions, means where they cross each other or intersect. Okay, the assignment, this one's going to be in the book. Page 211, numbers 1 through 12, and 16 through 20. That looks like it's missing. Let me fix that.